Hi guys, we are on lesson 10. It is page 95 of your workbook and it is called Operations with Numbers and Scientific Notation. So really it's just practice problems with scientific notation and standard notation. So exercise 1, we are given a problem that says the speed of light is 300 million meters per second. The sun is approximately 1.5 times 10 to the 11th meters from Earth. How many seconds does it take for sunlight to reach Earth? Okay, so in order to do this, let's say speed of light. We're going to change that to scientific notation of light, and is going to be 3 times 10 to the, I think it's 8, 1, 2, 3, 4, 5, 6, 7, 8, 10 to the 8th power. And now if we take the distance from Earth, the sun's distance, let's say sun's distance from Earth, and we divide it by the speed of light, then we should get how many seconds does it take for sunlight to reach Earth. So if we do that, we are going to get 1.5 times 10 to the 11th power divided by the speed of light, which is 3 times 10 to the 8th power, which is 1.5 divided by 3 times 10 to the 11 minus 8. Well, if I do that, I'll write that there. Okay, now we just divide them all. So 1.5 divided by 3, which is 0.5, times 10 to the 3rd power, which is the same as like 0.5 times 10 times 10 to the 2nd power. So I just wanted to show you this in a different format. I've really just been moving the decimal and changing it, but so this is the same thing, right? Because this is 10 to the 3rd power. So if I multiply 10 times 0.5, I get 5. And then times 10 to the 2nd. So that just makes it into scientific notation. So this is equal to 5 times 100, which is 500. So the answer would be it takes 500 seconds for sunlight to reach Earth. Okay, great. Exercise 2 says the mass of the moon, right? We're working in space right now. Space has a very large magnitude of numbers, so that is a place that you frequently see scientific notation. So the mass of the moon is 7.3 times 10 to the 22nd kilograms. It would take approximately 26 million moons to equal the mass of the sun, determine the mass of the sun. So if you take the mass of the moon and then you multiply it times the number of moons, you should get the mass of the sun. All right, so let's write this in scientific notation. This is equal to 2.6 times 10 to the 367th power. Okay, and now let's just fill it in and multiply it. So we have this number right here. I'll just do what is here. 7.3 times 10 to the 22nd, and then multiply it times 2.6 times 10 to the 7th. So we have 7.3 times 2.6, And you might wonder why I use x's again as multiplication. A lot of times when you see numbers in scientific notation, they're written with an x instead of a dot. So it's kind of us going backwards in time. All right, and then you have multiplying that 10 to the 22nd times 10 to the 7th, which is going to be plus 7, right? Using the product rule. And then we have 7.3 times 2.6, which is 18.98 times 10 to the 29th, which is the same as we have 1.898 times 10 times 10 to the 29th, right? That would be the same thing, which is the same thing as 1.898 times 10 to the 30th. So we had to kind of move the decimal the other way than in the previous problem, so that's how that's done. So to write that in our solution, we could say the mass of the sun is 1.898 times 10 to the 30th kilograms. All right.